What is up, YouTube? Today we're going to talk about binary search trees. Binary search trees. What are binary search trees? Let's just briefly go over what BST is. So binary search tree is everything compared to a root, which we are given. Everything on the left side is going to be always smaller than or compared to a root. However, everything on the right side, obviously, is going to be bigger than our root. So that's all binary search tree is. Root has 8. You can think of that as this. A tree always starts with its roots, right? So let's just draw a tree real quick. That is not what I wanted to draw. Let's just quickly draw a tree, right? Let's just have this is going to be a tree stumps. Yes, and okay, so this is a horrible tree, but you get the idea, right? So a tree always starts from its roots. Similarly, in a binary search tree, we always are going to start with a root. We are always going to start with a root, right? Everything compared, but as I said, everything on the left side is going to be smaller. Everything on the right side is going to be bigger. However, that is not something we're going to talk about today. What we're going to talk about today is going to be something called in-order traversal. What is in-order traversal? Basically, traversal, if I just spell this out real quick, traversal. Traversal just basically means going through our whole binary search string. Obviously, we want a way to basically go over this whole binary search string. So we want to go over 1, 3, 6, 4, 7, 8, 10, 14. That is what we want to do. So, but however, there are 3 main ways to do a traversal. An in-order traversal, a pre-order traversal, or a post-order traversal. Today we're going to talk about the in-order traversal. I'm just going to write in here, in or I should have written it here in order. You get the idea. In order traversal. We're going to talk about this basically. In order traversal. So, what is in order traversal? How we are going to print out the values or add values to a list is always going to be relative to our root. We're always going to be a left side, then going to go to a root, then going to go to our right side. For example, let's just look at this binary search tree right here. Always remember, going to go to the left side first, then our root, then our right side. Let's look at our example here. And I'm so excited to explain to you guys because this is a super cool concept. We want to always do our left side first relative to our root. Our 8 is our current root, right? So I'm gonna color this blue. Left side is always gonna be go first, root is going to go second, and right side is going to go third. Okay, so what we do is go to 3. And then we add no, we do not add 3. This is the interesting part. When we go to another node, we don't exactly print that out or add it, whatever you want to do with it first. What we do is number this is going to be our new root. I colored it in green. 1 is going to be our first thing, what we want to do. Our green side, what we color here is going to be second thing, and our 6 is going to be third. So below our 1 here, we don't have any values. These are going to be null. I'm just going to put n's as nulls. And what we do here finally is then add these values, right? We're going to cross out 1 here and add it to our list. Then we want to go to our second call, which is going to be sorry, which is going to be 3. So we want to cross that out and add 3 to our list. Do you think we should go to 2 or 3? 8 or 6 right here? Obviously, we want to go to 6 because it's totally okay if you got it wrong. Because when we want to go to the most recent call, and the most recent call we did was 3. And now we want to go to 6. Again, this is going to be our second part. We go to our new node, 4. What do we have below 4? Nothing. So we're going to print that out again. 1, 3, 4. We're going to go to 6 and then 7. after we cross these out, finally we go back to our 2 right here. So we go to our 2, we cross this out, and we're going to add numbers 8. Then we're going to go to numbers 10 and add 10. Then as I said, null here, so we can't go here. So we're gonna obviously add not 4, but like if we just do the same thing what we did here, we're gonna circle this, and it's going to be 1, 2, 3. So we're gonna finally add 14. So we're gonna do this. So it's gonna be 1, 3, 4, 6, 7, 8, 10, 14. This is what we're gonna do. Okay, guys, that's it. So remember, always go from our left side to our root to our right side. That's all we need to do. If you guys have any questions, please leave a comment. I will be a pleasure. It would be a pleasure to obviously answer you guys' questions. And yeah, let's get straight into the code. 1, 2, 3, and we are back. First thing we really need to do is create our array list outside of our method right here. So list integer, I just put it as x1 here. New array list. This is what we need to do. Second thing we really need to do is create another method that returns public void it. And it's going to, we're going to have tree node root. Tree node root with, second thing we really need to do is tree node root with input of our basic array list right here. List of integers x1. The reason why we're making another method in the first place is because we're gonna do recursion, basically. What recursion is basically, let's just say we have a print hello function, right? Inside of the print hello function, we're calling another print hello function. Basically, the main idea is basically calling the function upon itself. So it's simply just after I do this, return, not void, my bad, if root equals null. Okay, so I'm gonna show you right here. When the first thing if you guys remember, is we're going to go to our left side. Then we're going to print out our root or add our root, and finally go to the right side. So in order to keep on doing that, we're going to do something called recursion. Okay, the thing of what recursion is, that does not make any sense. What recursion is basically is we're calling the IT method in order traversal method again. Okay, so we're gonna do in order traversal root dot left. We're gonna do root dot right here and x1 as well. And in the middle, as I said, we always want to do left side first, then our root, then our right. Okay, so we want to add our root.val. Okay, so what it's gonna do if we just use example 2 as our basic example is we first get our 1, right? Our root is going to be 1. So the first thing we're going to do is dive into our left side. So boom, we are inside the left side. The root is now going to be 2. Inside 2, we're going to go to the left side again. Now going to be 4. But when we go left side of 4, there's nothing going to be added because obviously root is going to be null. So we don't do anything from that. Then we go to here. We're going to add 4. And again, on the right side, it's going to be null. So we go back to 2 and so on and so on. That's how it's going to work. But we can, if we don't have this function, right? This is not going to be possible because always we have to use recursion, but when we hit our null here, basically, we are not going to return some type of value. We just want to return void, basically. That's why we made another basically method, right? So just have root here and x1 here. And finally, we are going to return our x1, our list here. Okay. So if you guys have any questions regarding this, please ask in the comments. I'm pretty sure this is going to be correct. Yes, obviously. And this is going to beat 100%. If you guys have any questions, please leave a comment. Thank you so much.